Number 61. Element X and Y have the electronic configuration 2, 1. Let me rub this off so that we can have a space to write on. So element X has the electronic configuration 2, 1, and element Y have the electronic configuration 2, 8, 7, 2, 8, 7. Then the question now says, which of the following statement is correct? A. The bond between X and Y will be coordinate bond. B. The bond between X and Y will be covalent. Basically, the question is asking, what type of bond will be present? And maybe E. X and Y are reducing agent. First things first. If you look at this, we can see from here that this particular element X is an alkali metal. How do we know? It has one electron in an atomose shell. It means that this particular element here has atomic number 3 because that's 2 plus 1. And this element here belongs to group 7 in the periodic table and has atomic number 17, 2 plus 8, 10, 10 plus 7. And even it is evident here that this particular element S here is lithium because it has atomic number of 3. And this element here is chlorine. And what kind of bond is present between lithium and chlorine? That's LiCl. The kind of bond between a metal and a non-metal is ionic bond. So if you look at this, we will see that the correct option is option C. The bond between X and Y will be ionic. Ionic bond is also called electrovalent bond. The correct answer is option C. Number 62. The IUPAC name for NaHCO3 is, we refer to it as sodium hydrogen triisocarbonate 4. Sodium hydrogen triisocarbonate 4. So that's the IUPAC name for it. Option D. Number 63. The instrument used to measure the masses of isotopes, molecules, and compounds is dash. That is definitely a mass spectrometer. A mass spectrometer, among other uses, is used for measuring the relative abundances or masses of isotope. The correct answer is option B. Number 64. We are to calculate the number of moles present in 16 grams of carbon-4 oxide. If you want to calculate the number of moles, it is simply calculated by dividing the mass by the molar mass. The mass of CO2, according to this question, is 16. Then the molar mass of CO2 now is going to be carbon is 12 plus oxygen is 16. 16 times 2, that's 32. If you add it together, that's 44. So which means the mole now is going to be the mass, which is 16, divided by the molar mass, which is 44. And using our calculator, 16 divided by 44 gives us 0.36. 0.36. And if you look at the option, that is definitely option C there. So the correct answer for this is option C. Number 65. The purest form of naturally occurring carbon is none other but diamond. The purest form of naturally occurring carbon is diamond. Diamond is the hardest substance known. Not only that, it is one of the most sought after minerals because of its high economic value. Don't forget that the carbon atom in diamond is sp3 hybridized, and also diamond is used in making jewelry because of its high refractive index. So the correct answer for this is option D. Number 66. What defines the pH of a solution? The pH of a solution talks about the number of hydrogen ions. So it is hydrogen ion H+, that determines the pH of a solution. Even the formula, we can say pH is equal to negative logarithm of hydrogen ion to base 10. So you can see the hydrogen ion there. So the correct answer is option C. Let's go to number 67. The corrosion of metal, corrosion means rusting. The corrosion of metals results from the combined action of water and atmospheric oxygen. There are two major ingredients that are needed for corrosion or rusting to occur. There must be moisture, that's water, and there also must be oxygen, atmospheric oxygen. So the correct answer for number 67 is B. Let's go to number 68. What is the oxidation number of Y in this particular ion? This negative ion. Now, this is the negative ion. YO43 minus. Now, we can see that the overall charge is minus 3. So, we have to equate everything to minus 3. We need the oxygen number of Y, that's Y, plus the oxygen number of oxygen in all compound except in peroxide is minus 2. In peroxide is minus 1. So, this one is not a peroxide, that's minus 2. And since there are 4 oxygen multiplied by 4, and we equate everything to the charge on it, minus 3. So this is because Y plus times minus, that gives us minus 2 times 4, that's 8, is equal to minus 3. So this Y is equal to, if you take minus 8 to the other side, it becomes plus 8, and then Y, as you can see, is plus 5. So the oxidation number of Y in this anion is plus 5. And we can even say that that particular Y is definitely phosphorus, PO4 3 minus. After all, one of the oxygen state of phosphorus is plus 5. Don't forget that phosphorus also exists in plus 3. We have phosphorus 3 chloride, PCl3, we have phosphorus 5 chloride, PCl5. So the correct answer here is E, number 69. When delta H, that's the enthalpy change, is negative, the reaction is said to be, everybody knows that, that's C, exothermic. When the enthalpy change is positive, it will be called endothermic. But in this case, the enthalpy change is negative, so it is an exothermic reaction in which heat is released to the environment. Number 70. The rate of a chemical reaction can be altered, altered means changed, can be altered by the following factors, except. The question is asking us, which of these factors cannot alter or change the rate of a chemical reaction? Concentration will definitely alter the rate of a chemical reaction. Heat change accompany a chemical reaction. That's the correct answer. Heat change, the enthalpy change, has no effect on the rate of a chemical reaction. It neither slows down nor increases the rate of a chemical reaction. So the correct answer for this is heat change. Heat change has no effect on the rate of a chemical reaction. The correct answer for number 70 is B. Let's go to number 71. Which of the following exists as a diatomic molecule? Halogens are all diatomic, and we know that an example of halogen is iodine here. So iodine is diatomic. Don't forget that all noble gases are monoatomic. So argon is a monoatomic, gold is not monoatomic, it's not a diatomic, mercury is the only liquid metal, the same thing with silver. So silver is also not a diatomic. The correct answer here is iodine. That is why iodine is written as I2. And you can see fluorine, F2, chlorine, Cl2, bromine, Br2. So all these ones are diatomic molecules. So the correct answer for number 71 is C. Let's go to number 72. The compound 2-methylpropane is an isomer of, now, we know what an isomer is. When we're talking about isomerism, we are talking about the existence of a compound in 2 or more forms. And those forms will have different structural formula but the same molecular formula. If we're talking about 2-methylpropane, this is what we have. This 1, 2, 3. And this is the methyl group. The methyl group is attached to the second carbon atom, hence the 2-methyl. And the parent chain, 1, 2, 3. That's propane. So now if you look at this, we now want to find out of this which one has the same molecular formula as these 2-methylpropane. And the obvious answer is option A, butane. Because how many carbon atoms here? 1, 2, 3. And then plus 1 here, making 4. That's C4. What about hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's H10. And we know that C4H10 is butane. So 2-methylpropane is an isomer of butane. So the correct answer for number 72 is A. Number 73 now. hydrolysis of ethyl ethanoate yields ethanoic acid and dash. The correct answer here will be ethanol. Now, ethyl ethanoate has this formula, C2 CH3 COO C2 H5. That's ethyl ethanoate. Now, hydrolysis, that's plus H2O, and it's a reversible reaction to produce CH3 COOH, that's ethanoic acid, and then plus C2 H5OH, that's ethanol. So the forward reaction here is hydrolysis. Don't forget, the backward reaction is esterification. The reverse reaction of hydrolysis is esterification. So hydrolysis of ethyl ethanoate will produce ethanoic acid and ethanol. Ethanol. So the correct answer for this is option C. Let's go to number 74. An organic compound that decolorizes bromine water must be dashed. Now, bromine water is used to test for unsaturation. So which means an organic compound that will decolorize bromine water must be unsaturated. The correct answer for number 74 is definitely option D. Let's go to number 75. Cellulose and starch are classified as dash. We know that cellulose and starch are both polymers, or they are polysaccharides. So the correct answer for this is option E. Cellulose and starch are polysaccharides. Number 76. Elements in group 2 of the periodic table are known as alkaline earth metals. Elements in group 1 are called alkali metals. Elements in group 2 are called alkali earth metals. Elements in group 3 are called icosagens. Elements in group 4 are called tetragens or crystallogens. Elements in group 5 are called pnictogens. Elements in group 6 are called chalcogens. Elements in group 7, everybody knows that, are called halogens. And elements in group 8 are called noble gases or aerogens. So the correct answer for this is option A. Let's go to number 77. The chemical reaction in which two or more substances combine to form a single compound is definitely addition reaction. When there is combination of two or more substances to form a single compound, we say that an addition reaction has occurred. So the correct answer is an addition reaction. Number 78. An element X forms chloride Xl4. In which group of the periodic table is X? Remember, there is exchange of radicals here. So since you have Xl4, then X must definitely have 4 valence electron or belong to group 4 in the periodic table. Before we look at number 79, please endeavor to subscribe to our channel, like and share our videos to your learning colleagues. And don't forget to also put on the post notification bell so that you'll be promptly notified whenever a new and exciting video like this is uploaded. Thank you very much. Now let's go to number 79. Ammonia is manufactured from nitrogen and hydrogen by, the correct answer here is ABBA process. ABBA process is an industrial preparation of ammonia when nitrogen reacts with hydrogen in ratio 1:3. The catalyst needed for the ABBA process for the preparation of ammonia here is finely divided ion. So the correct answer here is ABBA process. If you are looking at solvent process, what is manufactured during solvent process is sodium triisocarbonate 4. This is what is manufactured during solvent process. So solvent process is used for the manufacturing of sodium triisocarbonate 4, whereas ABBA process is used for the manufacturing of ammonia. Number 80, A is 0.02 mole per dm cube of H2SO4 and B is sodium triisocarbonate 4 solution. If 18.5 cm cube of the acid, that's talking about H2SO4, was required to neutralize 9 cm cube of sodium triisocarbonate 4, we have to calculate the concentration of B in mole per dm cube. The very first thing we need to do is to write a balance equation for it. H2SO4 plus Na2CO3. That will give us, let's write the product here, that's Na2SO4 plus H2O plus CO2. Now, if you look at this, everything is balanced. 2 hydrogen, 2 hydrogen. Sodium is 2 here. 1 sulfur, 1 sulfur. Oxygen is 4 air plus 3 air making 7. There is 4 air plus 1 air making 5 plus 2 air making 7. And then carbon is 1, carbon is 1. So, which means that the mole ratio of acid is 1, and then the mole ratio of the base which is sodium carbonate is 1 here. And we remember the famous formula CaVa all over CbVb is equal to Na all over Nb. What do we want to calculate here? We need to calculate the Cb. That's the concentration of B. So if you make this one the same formula, we now have Cb is equal to CaVa Nb all over, then here we have NaVb, which is equal to Ca, that's the concentration of the acid, 0.02, times Va, that's the volume of the acid, 18.5, times Nb, that's 1, all over Na, that's also 1, times the volume of the base, we are told, is 9 cm cubed. So this is what we need to calculate now. So making use of a calculator, we have 0.02 times 18.5. That gives us 0.37 divided by 1 times 9. That's 9. So if you divide this by 9, we get 0.04. That's a mole per dm cube. So if you look at the option, you can see that's definitely option B. So let's go to number 81. The ideal gas equation PV is equal to nRT holds for all gases at, that is the ideal. Real gases behave as ideal gases at low pressure and high temperature. So if you look at the option, that's option C here. The ideal gas will hold for all gases at low pressure and high temperature. Option C. Number 82. Soap does not cause water pollution because it is biodegradable. One of the reasons, one of the advantages of soap over detergent, because there are some detergents that are not biodegradable, and because of that, when they get into water bodies, because they can be broken down by microorganisms, they clog the waterways. But soap do not have that particular problem. Soap actually can be broken down by microorganisms because it is biodegradable. So the correct answer for number 82 is B, biodegradable. Number 83 now. The process in which acid reacts with a base to form salt and water only is called neutralization reaction. So during titration, when an acid is titrated against a base, salt and water is formed, and we refer to such a reaction as a neutralization reaction. Number 84. When chlorine water is exposed to sunlight, the products formed are, let's look at the board and see. So, first of all, when you say chlorine water, what does it mean? That's, another name for chlorine water is oxochlorate 1 acid or hypochlorous acid. This is chlorine water. HClO. That's chlorine water. When chlorine water is exposed to sunlight, it decomposes to form hydrochloric acid, and then it liberates oxygen gas. So to balance that, 2 here and 2 here. So whenever chlorine water is exposed to sunlight, oxygen gas is liberated and hydrochloric acid is produced. And if you look at the option, you can see the correct answer is hydrochloric acid and oxygen. Let's move to number 85. Which of the following is correct about the element E? So you can see element E. Element E has the atomic number 19. And if this one is broken down into their shells, That's 2 electrons in the K shell, 8 electrons in the L shell, 8 electrons in the M shell, and then 1 electron. So if you look at this one, we can see it has 1 valence electron, and an element that has 1 valence electron are alkali metals. All elements in group 1 in the periodic table are called alkali metals, and all of them have 1 electron each in the outermost shell. As a matter of fact, the element that have atomic number 19 is potassium, and we know potassium is a group 1 element, which is an alkali metal. So the correct answer for number 85 is option B. Let's go to number 86. Calculate the percentage by mass of nitrogen in triosonitrate 5 acid. Let's take a look at that. Okay, triosonitrate 5 acid, that's nitric acid HNO3. If you calculate the molar mass, hydrogen is 1 plus nitrogen, atomic mass is 14, oxygen, the atomic mass is 16. 16 times 3, that's going to be 48. So if you add all of them together, then the molar mass is going to be 1 plus 14 plus 48. That's 1 plus 14 plus 48. That gives us 63. That's 63 gram per mole. But we are asked to calculate the particular mass of nitrogen. Nitrogen has an atomic mass of 14. So that's 14 all over the total molar mass, 63, multiplied by 100%. That's going to be the percentage of nitrogen. And using our calculator, 14 divided by 63 multiplied by 100 gives us 22.2%. And if you look at the option, that is definitely option D. So the percentage of by mass of nitrogen in nitric acid, which is triosonitrate 5 acid, is 22.2. Number 87. A given mass of gas occupies a volume of this. This is under gas law. Let's clean this up. So a given mass of gas occupies a volume of this. That's our volume 1, V1, is equal to 288.4 cm cube at 36 degrees Celsius. So which means T1 is equal to 36. But remember, we have to convert this one to the absolute value by adding 273 to it. 273 plus 36, that is going to give us in Kelvin. I'm making use of calculator. 36 plus 273 will give us 309. That's 309 Kelvin. And at a pressure of 750 millimeters of mercury, that's P1 is 750 millimeters of mercury. Now, what will be the volume? That is, what will be V2? V2 is unknown. When the temperature T2 is equal to 47 degrees Celsius. If you are converting this one to Kelvin, that's 273 plus 47 in Kelvin. That's going to be 273 plus 47. That gives us 320 Kelvin. And the pressure P2 is equal to 900 millimeters of mercury. We still remember the formula. P1 V1 over T1 is equal to P2 V2 all over T2. What we need to make with our formula is our V2. So our V2 becomes P1 V1 T2 all over P2 T1. So this will give us P1 is 750 times V1 is 288.4 times T2. T2 is 320 divided by P2. Our P2 is 900 times T1. Our T1 is 309. So everything in centimeter cube. So if you multiply the numerator now, numerator will give us 750 times 288.4 times 320. Then we divide by 900, divided by 900. Then we divide again by 309. divided by 309. And that is going to be 248.9 centimeter cube. And if you look at the option now, 248.9 can be approximated to 249 centimeter cube. So the correct answer is option C. Let's go to number 88. Calculate the mass of carbon dioxide, that's carbon dioxide formed, when 3 grams of carbon is completely burnt in oxygen. So, okay, before we look at number 88, kindly remember to subscribe to our channel and don't forget to put on that post notification bell so that anytime an exciting video like this is uploaded, you'll be instantly notified. Thank you very much. So let's look at number 88. We have to calculate the mass of carbon dioxide that is formed when 3 grams of carbon is completely burnt in oxygen. We have to write the equation for carbon in solid form, burnt completely in oxygen. We know that when carbon undergoes complete combustion, it's going to form carbon dioxide. If it is incomplete, it's going to form carbon dioxide. So we can see that the ratio is ratio 1 to 1 to 1. So which means the number of mole of carbon will also be equal to the number of mole of CO2. Let's calculate the number of mole of carbon here. The number of mole of carbon is going to be the mass of carbon, which is 3 grams, all over the molar mass of carbon, which is the atomic mass, which is 12. And if we divide this, we can remove this gram here. This one will give us 1 all over 4, which is 0.25 mole. What that means is, since the number of mole of carbon is the same as number of mole of CO2, which is ratio 1 to 1, it means that the number of mole of CO2 is also equal to 0.25. Now, we need to calculate the mass of CO2. What is the molar mass of CO2? Molar mass of CO2. Carbon is 12. Oxygen is 16. 16 times 2 is 32. That's 32. So if we add it together, that gives us 44 grams per mole. So we know that mass is equal to the number of mole times the molar mass. What's the number of mole of CO2? 0.25 times the molar mass of this is 44. And when we multiply it, what do we get? That's 0.25 times 44. That gives us 11. That's going to be 11. So the correct answer for number 88, as you can see here, is option D. Let's go to number 89. Now, 100 cm cube of a gas diffused in 12 seconds. Calculate the rate of diffusion of the gas. That's a simple calculation because we know rate of diffusion is equal to the volume of the gas that diffused by, then you divide the time of that particular diffusion. Rate of diffusion is equal to the volume of the gas all over the time taken for it to diffuse, time taken. And according to this question, the volume of the gas is 100 cm cube. That's centimeter cube divided by how many time? What is time? That's 12 seconds. That's 12 seconds. And using our calculator, 100 divided by 12 will give us, this gives us 8.3 centimeter cube per second. So looking at the option, the correct answer is option C, which is 8.3 centimeter cube per second, even though the unit is not stated there. Let's go to number 90. Which of the following methods is important in food canning industry? Now, a lot of food are preserved, are actually sold in cans. Talk about geisha and the rest of them. They are in cans. And the kind of methods that are used are those methods that are not react, that they won't be able to react with the content. And the obvious choice here is aluminum. Aluminum is passive. It won't react with whatever is put in that particular canned container. So the correct answer for number 90 is option A. Let's move to number 91. Temporary hardness of water is removed by, definitely, by boiling. Now, there are two substances that are responsible for causing temporary hardness of water. Those two substances are calcium hydrogen triisocarbonate 4 and magnesium hydrogen triisocarbonate 4. So there are several ways by which temporary hardness of water can be removed. One of the methods is by boiling. Another method is by adding calculated amount of slaked lime, which is also called calcium hydroxide. Another method is distillation, and so on and so forth. But the obvious choice here is boiling. Number 92. Which of these alkanols does not give a visible reaction with Lucas reagent? Now, Lucas reagent is a reagent that can be used to distinguish between the three classes of alkanols: primary alkanols, secondary alkanols, tertiary alkanol. Now, when Lucas reagent is added to a tertiary alkanol, it becomes turbid instantly, immediately. On the other hand, when Lucas reagent is added to a secondary alkanol, it doesn't form turbidity right away. You have to heat it for about 5 minutes before it becomes turbid. And finally, when you add Lucas reagent to a primary alkanol, nothing actually happens. It doesn't form turbid even after you must have heated it. So the correct answer here is option A. Lucas reagent will not form any visible reaction with a primary alkanol. An example of a primary alkanol is ethanol. An example of a secondary alkanol is butan-2-ol. An example of a tertiary alkanol is 2-methyl-propan-2-ol. So the correct answer once again for number 92 is option A, primary alkanol. And by the way, Lucas reagent is a mixture of zinc 2 chloride and concentrated hydrochloric acid. Let's go to number 93. When excess ethanol is heated with concentrated H2SO4 at 130 degrees Celsius, the product obtained is dash. Now, excess ethanol is C2H5OH. Now, when we say heated with concentrated H2SO4, we know the role that conc H2SO4 will do here. It's going to serve as a dehydrating agent to remove 1 mole of water, and the temperature is 130 degrees Celsius. Since the ethanol is in excess, like 2 moles here, now when 1 mole of water is removed from it, the product is going to be C2H5O, C2H5. And the name for this one is diethyl ether. Another name for it is ethoxyethane. And if you look at the option, the correct answer here is option C. It can be called ethoxyethane. It can be called diethyl ether. After all, C2H5 is ethyl, and there are 2 of them, hence the name diethyl ether, because an ether is an organic compound that have the general molecular formula ROR, where R and R prime are alkyl group that can either be the same or different. Now, this can be confusing if you are not paying attention. If ethanol is in excess and the temperature is less than 160 degrees Celsius, it is an ether, ethoxyethane, that will be produced. On the other hand, if you are eating excess concentrated H2SO4 with ethanol at a temperature that is way higher than this, say 180 or 170, then the product obtained will have been ethane. This is what we will have gotten. We will have gotten something like C2H5OH, this ethanol, and then here we have our concentrated H2SO4, which will remove water molecule, and let's say the temperature is 180 degrees Celsius. Then the answer will have been C2H4 gas. So take note of that. If the ethanol is in excess and the temperature is lower than 160 degrees Celsius, it is an ether, ethoxyethane or diethyl ether that will produce. On the other hand, if the temperature is higher, say 170 or 180, and it is the concentrated H2SO4 that is in excess, not ethanol, then the product obtained will be ethane. So the answer for this, number 93, is ethoxyethane. Number 94. The following are addition polymers except. Now we know that we have two types of polymerization. Addition polymerization, condensation polymerization. The difference between the two of them is simple. During addition polymerization, several monomers combine to give a single polymer. That's all. But in the case of condensation polymerization, two or more monomers will combine together to produce a condensation polymer, and then there is elimination of small molecules of substances like water, hydrochloric acid, and hydrogen chloride gas rather, and ammonia. Now looking at the options here, terylene is definitely not an addition polymer. Terylene and nylon are examples of condensation polymers, whereas polyvinyl chloride, polyethylene, polystyrene, perspex, all of them are examples of addition polymer. Terylene is used in making fabrics. Terylene is actually also called dacron, D-A-C-R-O-N. PVC is used in making pipes. All these polyvinyl chloride is used in making pipes. Polyethylene is used in making all these poly bags that we use in carry things around. Polystyrene is used in making all the disposable food disposable materials used in making all these food packing substances. Not only that, it is used in making crates of eggs because of its high compressibility. It's used in packaging and transporting fragile materials. If I'm talking about perspex, we all know contact lenses. Perspex is used in making it. Not only that, perspex is used in making the rear light of cars. It is gas-like in nature. It's like glass. The only difference between perspex and glass is glass doesn't scratch easily, but perspex does. So the correct answer for this is terylene. Terylene is not an addition polymer. It is a condensation polymer. The same thing with nylon. Nylon is equally a condensation polymer. Number 95. The product obtained when starch is warmed with dilute hydrochloric acid is dash. The answer will be glucose. Starch is a polysaccharide. When a polysaccharide is warmed with a dilute acid, the dilute acid will hydrolyze. Hydrolyze means to break a complex substance into a simpler substance. The complex sugar, which is starch, will be broken down or hydrolyzed into a monosaccharide, which is glucose. But care must be taken here. If the acid is not in dilute form, but rather in concentrated form, then the HCl will no longer be hydrolyzing the starch, it will be dehydrating it. So if the question had stated that the product obtained when starch is warmed or heated with concentrated HCl, then the answer would have been carbon. So when a concentrated acid is heated with a starch, it will become dehydrated to carbon, a charred carbon. The word charred means blackened. But when starch, in this case, is warmed with dilute, emphasis on dilute HCl or dilute H2SO4, then the starch will be hydrolyzed to produce glucose. So the correct answer for number 95 is B, glucose. Number 96. Detergents are made with straight chain hydrocarbons so as to make them biodegradable. So whenever one of the disadvantages of detergent is the fact that they easily cause water pollution. And why do they cause water pollution? They are not easily broken down by microorganisms, so they begin to accumulate in water bodies, therefore causing water pollution. But there is now a way to make them to be biodegradable, and that's by making them of long chain or straight chain hydrocarbons so that bacteria will be able to break them down. So detergents are made with straight chain hydrocarbon in order to make them biodegradable. Let's move on to number 97. Which of these chlorinated alkanes is used in fire extinguisher? Now, if you are not careful here, you are going to go with option A, which should be wrong. Even though carbon oxide is used in fire extinguisher, is carbon oxide a chlorinated alkane? No. So, options B to E are chlorinated alkane, but which of them is actually the correct answer? The correct answer is option E, tetrachloromethane. Why is that? Because tetrachloromethane is non-combustible. It is non-combustible. It doesn't support combustion. Because of that, it is used in fire extinguisher. Don't forget that tetrachloromethane, apart from the fact that it's used in fire extinguisher, it is also used as a solvent in industry for removing stains. The same thing if you are talking about CHCl3, that is trichloromethane, it is sometimes used as an anesthetic, and also it is also used just like CCl4 as a solvent in industry for removing stain. So the correct answer here, the chloroalkane that is used in fire extinguisher is CCl4 because it is not combustible. Number 98. Chlorine is suitable for the bleaching of the following except. So the question is essentially asking, which of these is chlorine not suitable in bleaching? We all know that chlorine is a good bleaching agent. As a matter of fact, we know that chlorine bleaches by oxidation. What does that mean? When chlorine bleaches a material, it bleaches it permanently. The color cannot be regained again. That is different from SO2. SO2 is also a bleaching agent. However, SO2 bleaches by reduction. So which means the color can be regained by reoxidation. So back to the question here. Out of all these options, which one is chlorine incapable of bleaching? Anything that contains carbon, chlorine is unable to bleach it. And we know that printer's ink contains carbon. So the correct answer here is printer's ink. Chlorine can bleach all material, but any material like printer's ink that contains carbon cannot be bleached by chlorine. So the correct answer for number 98 is C. Let's go to number 99. Which of these oxides will remain unchanged when jets of hydrogen gas is passed over it? We know that hydrogen is a good reducing agent, but hydrogen is not strong enough as a reducing agent to reduce an oxide of an electropositive metal like zinc 2 oxide. As a matter of fact, oxides of things like K2O, oxide of potassium, oxide of iron, oxide of calcium, oxide of magnesium, aluminum oxide, and also zinc oxide. All these oxides are too strong for hydrogen to reduce. Other oxide like copper 2 oxide, tin oxide, lead oxide can easily be reduced by hydrogen gas. But oxide of zinc, because zinc is a highly electropositive metal, the oxide of zinc is too strong for hydrogen to reduce. Hydrogen is not strong enough to reduce an oxide of zinc to metallic zinc. So the correct answer for number 99 is C. Let's go to the last question. Which of these is used during manufacturing of butter? We know that butter and margarine are manufactured during hydrogenation, or we refer to it as catalytic hydrogenation of fat and oil. That is when fat and oil are heated with hydrogen in the presence of nickel as catalyst at a temperature of about 180 degrees Celsius to 200 degrees Celsius. So it is definitely hydrogen. Hydrogen is used during catalytic hydrogenation of fat and oil to manufacture butter and margarine. So the correct answer for number 100 is A. Thank you very much, and please subscribe to our channel, like and share our videos, and don't forget to put on the post notification bell so that you'll be instantly notified when exciting videos such as this is uploaded. See you next time.